We're going to find the component form and the magnitude of vector v that has the initial point of 2, 3 and the terminal point of 7, 5. So here's some things we have to know. I'm going to start here. This is my p-value. And I'm going to end here at my q-value. So when I draw it, I start from the initial to the terminal, which gives me the direction of my vector. A vector is really comparing the horizontal with the vertical, or the radius of the cosine of the angle, comma, the sine times the radius, which is x, comma, y. So we're really looking at the horizontal and vertical distances. So if I was going to compare this one right here to find the vector in component form, I'm looking at my horizontal distance. Well, to get from here to here is a horizontal distance of 5. And my vertical distance from there to there is a vertical distance of 2. But mathematically, we need to be able to prove it as well. So what I'm looking for to do it mathematically is we're taking the terminal x value and subtract the initial x value to find the distance between the two. And then the terminal y value, subtract the initial value to find the distance. Therefore, my component vector is right here. Now it also says to find the magnitude. The magnitude is the distance of the vector. So there's a few ways I can find that magnitude. I can find the magnitude by, I have a right triangle right here. Well, if I know the horizontal distance is 5 and the vertical distance is 2, by the Pythagorean theorem, a squared plus b squared equals c squared will give me 4 plus 25, which is the c squared. Therefore, c, or the distance of that vector, or magnitude, is the square root of 29. So this distance right here is the square root of 29. Well, mathematically, we can say our magnitude, so the way we know magnitude is PQ with the double lines here, is the distance formula as well, which is Q1 minus P1 quantity squared added together with the Q2 minus P2 quantity squared. Again, the distance formula. So if I want to do it mathematically with the distance formula, you can take that 7 minus 2 squared plus 5 minus 3 squared, and in turns get 5 squared plus 2 squared, which equals the square root of 29. Another way you can look at it too is you can say, okay, well, if you have your component vector, it's your x squared plus your y squared, which in turns gives you that same piece. So regardless of what way you look at it, the distance formula or the Pythagorean theorem, you're going to come up with the same magnitude. One other piece I want to look at, even though it didn't ask me to find it, is because we know so much using our trig lately, I can figure out what this angle is right here so I can see the angle that it's growing from my horizontal and vertical distance. Well, I know I have the opposite and I know I have the adjacent, so I can look at the tangent of theta is going to be that 2 over 5. So when I find that angle, make sure my calculator's in degrees, because remember we're going to take the inverse of it, I can say that angle is approximately 21.8 degrees. So from this problem, we can find a few different things.